So today's lesson is a continuation of what we did last time. So if y'all felt like last time was pretty okay and you got it, we're just going to do more of that. This time, though, we're going to have multi-step equations with the variable on both sides. I just want to review what we did last time. Do you remember order of operations? What's our little acronym we did for that? PEMDAS. Okay, it's please excuse my dear Aunt Sally. Multiply and divide goes together. Add and subtract goes together. But when you solve an equation, you do that in what order? Backwards. We're going to go backwards. You do the add and subtract first because you're trying to undo what's there. Do you remember the socks and shoes analogy? You put on your socks, you put on your shoes, then when you go to undo it, how does it work? Take off your shoes, then take off your socks. You come to class prepared, yeah? Well, I had a bunch of pencils in the drawer on my desk and they've all been taken, so I'll have to go and get it. You just have to twist it. All right, so we're going to do that in reverse order. Also, if you have parentheses, the first thing that you need to do is distribute. Distribute through the parentheses. If there are any parentheses, if there's not, then don't, Distribute, combine like terms. And I was talking about that with my class yesterday. Here, let me write that a little bit better. Writing and talking at the same time, I'm struggling here. Combine like terms. You usually know that you need to combine like terms if your statement's really long. Like if you look at it and it's about this long, you need to combine stuff to put it together. Does that make sense? Just like logically, like if it looks too big, you have to combine stuff together. Okay. Now for these ones, I'm going to add to that list. We wrote that last time, distribute, combine like terms. Now that you have a variable on both sides, you have to get them all to one side. And it's generally just best if you move the variable to the left side. Okay. So move the variable to the left. It's not wrong if you move it to the right, but we read our papers left to right. Do you get what I'm saying? And it's generally just easier if you move the variable to the left. If you do it the other way around, fine. Like as long as you get the right answer, I don't care. However you get a right answer is fine with me as long as it's not cheating. You do you. There's so many ways you can get the right answer. But I'm going to say move the variable to the left, and I'm going to do it that way just to be consistent because I'm doing the problem in front of a whole group of people, so I have to stay really consistent. All right, here we go. Looking at the first one, I don't see any parentheses, so I don't need to distribute. It's not super long, so I don't need to combine like terms. We're going to get the variable all to the left side. So how would I remember you want to undo what's there. How would you undo a minus 17m? Yeah, add. So plus 17m, and you want to line them up. Like, do you see how when I wrote it on the other side, I wrote it below the other m's? Like, a lot of mathematics is just staying organized. It's not really about intelligence at all. It's really about staying organized. Because I've met people who are absolute geniuses, like completely brilliant, and they can't get right answers because their thoughts are just all over the place. Like, stay organized. All right, negative 7m plus 17m. What's that going to give us? Good, 10m plus 20 equals negative 10. Good, negative 10. That negative stays with the 10. Now it's exactly like what we did last class. Now what? You want to get the variable by itself. So what would be the next step? Subtract 20. And again, you would always be allowed a calculator. I require the Chromebooks be put away while I'm teaching because I want you to be focused. If there's anything we need to type in, I'll bring up the calculator. All right, bless you. 10m equals negative 10 and negative 20 would be negative 30. Very good. Perfect. And then last step, why are we dividing? Because it's being multiplied, we want to do the opposite, so divide. So m equals, you guys are wonderful. We're just going to practice a whole bunch more of that. This next one has a fraction, so look out. Also, it has parentheses, so we're going to need to distribute. All right, so we're going to take that 1/3 and distribute it through there. Multiplying by 1/3, oh good, is the same as dividing by 3. Remember in a fraction, this bar means division. You're just dividing by 3. So thank you. 12 divided by 3 would be 4. Minus, and then 1/3 of 6x. 2x, good. The x is kind of like just there. Equals 4 minus 2x. Oh my gosh, Do you remember what happens if you get the same thing equals the same thing? Do you remember that from last time? We'll go over it again. So it's one or the other of those. Let's review. If you get something that makes no sense, like 2 equals 1, like something that's just completely bananas, that means no solution. And if you get something that's true all the time, that's infinitely many. Good. So this answer would be infinitely many solutions. You can just write infinitely many. Give me a number. That works. That works too. That works too. 0 works too. People usually ask about 0. What about 0? Every single number in the world will work. Yeah, and they would make choices like A, 3, B, -7, C, no solution, D, infinitely many. It would be multiple choice like that. Yeah. Infinitely many. All the solutions in the entire world. You'll get used to it. We'll practice. I think there's a few on here that are like that. All right, next one. Do you see those parentheses? What does that mean we have to do? Distribute. So again, this one's a 1/3. That means you're dividing by 3. So distribute a 1/3. That would give you what? 3K plus, good, 1. A third of 3 would be 1 equals, and then on the other side, you're not distributing 2, but -2. Good. And that's why I tend to circle the number I'm distributing. That kind of helps if you want to do it. So that would be -2K. Good, plus 16. Negatives cancel. -2 times -8 would be plus 16. Now it's not super long. We don't have terms to like combine or anything. You want to get the variables together, and my like advice is move it to the left. So I would add this 2K to the left side. If you move it to the right and get the right answer, fine. That's totally fine. I like right answers, so it doesn't really matter to me. All right, so what do we have on the left? 5K plus 1, perfect, equals 16, almost there. Subtract the 1. 5K equals 15. And you would divide by 5. I'm sorry, I kind of ran into the next problem. Divide by 5, K equals 3. This next one has a great big fraction in it. Just remember, fraction bar means what? What does the bar mean? How do you undo divide? Undo division, we multiply. So we want to multiply both sides by 7. Good. Fractions scare people. Just remember it means division. So to cancel it out, you're going to multiply. So 7s will cancel. That will be 9 minus 2y equals 7y. I just got done saying always move the variable to the left. We can still do that. However, in this one's kind of weird because there's no other, do you see how there's no other number over here? So this is one of those kind of rare situations where I would maybe like move the variable to the right. Are you following me there? Because there's like no other number. So let's add the 2y over. At the end of the day, it really doesn't make a difference. So that would give us 9 equals 9y. Now, oh, I heard somebody say infinitely many. Let's talk about that because that's like all like it's really close. If you got 9 equals 9, then yes, that would be the answer. But it's 9 equals 9y. So we actually have one more step. Divide by 9, good. And so y equals 1. Yep, good. How are we feeling? Good, bad, okay? Yes, you would still get 1 if you moved the variable to the left side. Works out the same either way. All right, I see parentheses. What does that mean we have to do? Distribute. We're going to distribute the 3. So that will give us 3x plus 3 equals, and then that side's just 3x plus 7. Again, a lot of math is just recopying what's there. Instead of being annoyed by that, be happy about that. Like, oh, I don't have to do anything, just rewrite that. Now you have 3x on both sides. So if you try to get those together, like if you try to subtract this 3x, what's going to happen? Yeah, like, so you get 3 equals 7, and 3, well, last time I checked, 3 does not equal 7. So that one is no solution. So give me a number. That will not work. That will not work. That won't work either. No number in the entire world will work, which is kind of a cool answer, actually. This equation is a liar. I see parentheses. So we are going to distribute this 2. So that will be 3 plus what? If we multiply a 2 there. 10x good minus 2. You're just multiplying the 2 to both parts of that. Equals, now actually this is a little tricky because you see parentheses, so that makes you think like, oh, I want to distribute. But do you see how there's nothing like else in there besides the negative 5x? Yeah, like you just multiply them together. There's nothing to like distribute to. I guess you could draw the little rainbow if you want to, but you're just multiplying those together. So negative 2 times negative 5x, 10x good plus 1. Combine like terms. Do you see how it looks really long? We want to kind of squish it together. What's going to go together? I'll use another color here. Yeah, 3 and not 2, but negative 2, good. That'll be 1 plus 10x equals, oh, 10x plus 1. So I got 1 plus 10x equals 10x plus 1. Are those the same thing? Those are the same thing. So what's our answer? Infinitely many. Let me bring this up really quick though. Let's say it had been 1 minus 10x equals 10x minus 1. Are those the same thing? No, subtraction you cannot flip around, and here's why. Humor me for a second because I want you to understand this. What is 7 minus 4? 3. What is 4 minus 7? See how they're not the same? So addition you can get away with that with, but subtraction you can't. All right, so for number 7, I see parentheses. What does that mean we're going to do? Distribute. Use your brain. Yeah. See, you're good at using your brain. Where you're struggling is getting the work done. No, your homework was done. I wasn't talking to you. All right, so distribute the 3. That will give us 3x plus, not 1, 3. Good. Plus 1 plus 2x. That stuff's kind of just there. Like you just have to write it. Equals. All right, here I'm going to distribute the 2. Wow, there's like a ton of 2's in this problem. If you multiply the 2, what are you going to get? 4x good plus 4. And then plus x is kind of just there. You have to just write it. I'll just keep giving you pep talks. Just write it. You can do it. It's easy. You don't have to do anything except write it down. Now this thing is really, really long. So what do I want to do to like get it together? Combine your like terms. All right, I'll use another color. Let's see what can go together here. 3x can go with what? 2x, good. That will give us 5x, good. Bless you. All right, and then 3 plus 1 will give us 4. Equals, and then on the other side, let's see, 4x plus x will be 5x. Oh my gosh, plus 4. Good, infinitely many. I don't mind that you're having a snack, but you have to pay attention and write it down too, or we can, okay, just making sure. I believe you. What's that? This is Algebra 1, yeah. Yeah, what you did last year was like pre-algebra. We're starting out with this, but we're going to go way further than this. So it's like, this is where our starting place is, and we're going to go beyond. If it seems easy now, though, just be happy about that and get your work done. All right, number 8, we're going to distribute the 3. That will give us 6x plus close, yeah, 12. Sorry, I thought that was an 8. My bad. All right, equals, and then distribute the 6 on this side. That will be 30x plus 12. So if you have a choice or it seems easy, like my advice is get the variable to the left side. So I'm going to subtract the 30x just because we read left to right. I realized there was that one on the other side of the paper. We moved it to the right because there wasn't like another number there. But if you have a choice, move it to the left. 6 minus 30. We'll do 30 minus 6, but then just make it negative. It'll be negative 24x, good, plus 12 equals 12. Hey, guys, are you together back there? Not yet. First, we're going to subtract 12. Why am I subtracting 12? Because it's positive 12. And that's going to be negative 24x equals 0. And then usually that's where people hit a roadblock in their mind and they're like, wait, what do I do? Pretend it's not 0 and just keep going. Pretend it's any other number and just keep going. What would you do next? Divide by negative 24. 0 divided by literally anything is 0. It's not no solution. We got an answer. The answer is just 0, and that's okay. 0 is a valid number. Yes, ma'am. Correct. And that's the reason why when you do 0 divided by anything, you get 0. Except 0 divided by 0. You'll have to wait till calculus for that one. All right. Write an equation to represent each situation and then solve it. So the only difference down here is you're going to have to write the equation yourself, which means reading and using your mind, okay? 9 less than, remember that than is going to flip it around. So it's going to be something minus 9. 9 less than 5 times the number. Let's go ahead and just stop there. How would I write that? Well, it's going to be 5 times x minus 9. Good. We want 9 less than. It's like if I said I was 9 inches shorter than somebody. I mean, I'm short, I'm not that short, but if I was 9 inches shorter than you, you would take your height minus 9. So 5x minus 9 is, so what comes next? Good, equals twice the sum. So when you see sum, that means you need parentheses. Good, so it's going to be 2 times the sum, and in those parentheses, we'll have to put adding something. Good, x plus 6. Now the problem is exactly like what we've been doing. You just had to write it yourself. And I said this last time, but I'm going to say it again. If you lose your mind, make up an equation and solve it. I'm not joking. I can give you partial credit for that. But if you leave the problem blank, I can't help you. Right? What are we going to do with this 2? What's our first step here? Distribute. When you see parentheses, you're going to have to distribute. So 5x minus 9 equals 2x plus 12. And I get that some of you are doing some of these steps in your head. Please write everything for me. And I always have to say this to my pre-calc students too. I can't grade what happened in your mind. My telepathy is not functioning properly, okay? I can only grade what's written on your paper. So you have to write it for me, all right? What next? We want the variables together. Move them to the left. Minus 2x, perfect. That will give us 3x minus 9 equals 12. And then what? Plus 9. I'm going to have to come over here. Plus 9. So that'll give us 3x equals 21. 12 plus 9, 21. Sure, I did that right in my head. All right, and then last divide by 3, x equals 7. These are all coming out to whole numbers, but if you got a decimal, does that matter? No, every once in a while that happens and you just, go with it, okay? All right, taxi company A charges $8 to get in and then 75 cents per mile. Let's write a statement for that. It's not an equation yet, but just how would we write that? $8 to get in and then 75 cents per mile. Good. Where x represents what? Miles. Good. X is miles. Taxi company B charges $3 to get in and then $1.25 per mile. What distance, so X, meaning miles, what is X for it to be like the same, so equal to each other? So we're going to put equals, and then what would be our statement for company B? Good. 3 plus 1. So they charge less initially. It's only $3 to get in, but then they charge more per mile. So we're saying, well, how far would you have to go for it to not matter? All right, what are we going to do to both sides first? You want to get the variable to the left. Good. Subtract the 1.25x. 0.75 minus 1.25. Think of money, like think you're holding quarters in your hand. If you have 75 cents, but you owe 125, you would be short by how much? 50 cents. So it would be 8 minus, yeah, but you can actually just write 0.5, or you can put the 0 at the end. It actually doesn't matter. You can put as many zeros as you want after that. I'll put 0.50 because we're kind of thinking about money here. Equals 3. And then what? Subtract, not the 0.5, the 8, good. But you're left with not 0.5, but negative 0.5. Oh, and then over here, 3 minus 8, which is actually good because X can't be negative. Those negatives have to cancel because remember, X represents miles and you can't have negative miles, okay? So those negatives are gonna cancel and we're gonna divide by 0.5. Now, 0.5 is a half. Dividing by a half is the same as multiplying by 2, because 1/2, if you do a reciprocal, you get 2. Sammy. Well, it can't be negative because it's miles. So the negative's canceled, so it will be positive. What you're doing is 5 times 2, so just 10. 10. So X equals 10 miles. And again, you would be allowed a calculator in any situation. You could type in 5 divided by 0.5. I was just trying to talk to you. Okay.